Hi everyone. In this video, we will work on homework 1, number 47, where the integrand is in a fraction format, 3x plus 1 divided by x squared plus 1. Okay, we need to decide what technique to apply. Could we use the algebra to simplify this? There's a possibility. For example, 3x plus 1 over x squared plus 1. We can separate the numerator, right? To rewrite this one as the sum of the two fraction terms. This is a possibility, right? But no matter what, we still need to deal with the integrand of the fraction terms, which involves the x squared plus 1 in the denominator. We can consider the u substitution. The one reasonable choice will be u equal to x squared plus 1. Taking derivative, we have 2x, or dx written as du over 2x. Now it's time to rewrite the definite integral. Okay. 3x plus 1, we can leave this term. Denominator becomes u right now. And then dx is du over 2x. Okay, so here is the same. It seems that we cannot do the cancellation for this because in the numerator we have the plus and denominator have 2x. However, here is how the algebra can come into the play, because we can separate this 3x over u plus 1 over u and then du over 2x. Okay, that means 3x over u du over 2x plus 1 over u du over 2x. Okay, then from here, since we have already separated this one, we can cancel this x. Okay, and now we have this term. Even though the first term is doable, but it seems that the second term still involving the x. Then we might think, what's wrong with this u substitution? Okay, and then I guess we will need the second page to this one. Let me rewrite the questions. 3x plus 1 over x squared. 3x plus 1 over x squared plus 1 dx. As I mentioned before, for this one, it might be better to apply the algebra first to separate this, because we can apply different technique to these two individual terms, right? So here we can consider to apply the u sub. For the second one, because of the structure special format, 1 over x squared plus 1, the antiderivative is actually available. We do have a formula, tangent inverse x. If we take a derivative, that will be 1 over x squared plus 1. Okay, now we only need to deal with the first term, which is the u sub. All right, now as before, we choose u to be x squared plus 1. Du over dx will be 2x, dx will be du over 2x. Now we rewrite only the first term on the right-hand side, where the numerator will be 3x. Okay, and u du over 2x. All right, now in this case, as before, we can cancel this x, so the answer will be this 3 over u and then du. Obviously, the antiderivative involves the natural log of u. Of course, we have 3 as coefficients. 3 over 2 as coefficient. I guess I forgot the number 2 here. Okay, now a quick summary. The original problem is this one. We need to separate this into two terms. So we will have the flexibility to apply different technique for each term. Now the first term we apply the u sub. we got the answer 3/2 natural log of u, which u is x squared plus 1. So we can replace here. The second term, the antiderivative is available immediately, tangent inverse of x. Finally, add a constant c. Okay, so this is for these problems. Again, the one takeaway from this is consider to apply the algebra technique before we consider the u substitution. Or when we apply the u substitution, we can figure out a pattern and decide that which algebra technique will be